Hey, good morning or good afternoon, depending on where you are, and welcome to our webinar about RFC security. We see there are still a number of people joining right now, so we'll give them another minute or so, and then we'll get started. So hang tight for another minute, please. All right, let's get started. Again, welcome everybody to our webinar about RFC security and how to design custom authorizations and avoid pitfalls doing so. Today's presenter is going to be Marc Spitzer from our German team, and he's very well versed in RFC security, so he'll walk you through most of the slides. A couple of housekeeping questions before we get started. One is there is a questions box in the GoToWebinar control panel. So if you have any questions about anything that you see or hear, please type in your questions. Alessandro and I will do our best to answer those questions as we go, because we only have 30 minutes today, so we're not going to have a Q&A session at the end. Anything that we can't get to, we'll follow up via email and make sure we answer all of the questions that that you guys might have. And with that being said, I'm going to try, and also the webinar is going to be recorded, so you'll get a recording in case you have to drop off early or something like that or want to share it. So no worries about that. And you will also get a copy of the presentation in the follow-up email. And with that said, I'm going to hand it over to Marc. Marc, if you want to introduce yourself real quick, and then let's get started.
Yeah, sure. Thank you, Michael. So as Michael said, my name is Marc Spitzer. I'm at Xiting as a consultant in Germany and specialized in SAP security and doing various projects in this area, redesigns for technical users, RFC users, batch users in particular, but also a lot now with S4 migration, S4 redesigns in this area. Also a well-known topic, and today, especially for introducing you to the topic of RFC security, on how to design custom authorizations, also how to design the RFC interface is also a very important topic, and how these two things are connected together. And I will give you some best practices from my redesigns and how to avoid pitfalls in doing these optimizations, redesigns regarding authorizations, or also designing the RFC interfaces. So let's get started. So a bit too exciting. We are founded in 2008 in Switzerland, and I am also in Germany. So we opened their subsidiary in 2012, it's also the time when I started with subsecurity. And since then, we expanded to United Kingdom, United States, and also Romania. We have a lot of partner sales with SAP, other companies where we are using synergies in services, consulting, and software. And at the time now, we have over 80 employees worldwide, I think 85 at the moment, something like that. And we are sub-silver partner and also sub-recognized expertise in governance, risk, and compliance. So short introduction to Xiting. I don't want to waste a lot of time on that. So we have more time on the important topics today. This is the agenda for today. Short, I want to introduce you to the RFC basics and also the risks assigned to having RFC authorizations with a lot of wildcards. So we will have a short look at that, looking at how RFC communication with the RFC interfaces is handled and the risks involved with that. Then we will have a look on how to analyze RFC interfaces and also maybe optimize RFC interfaces, because the second and third point here, the third point, how to optimize the authorizations, is the goal of today. To optimize the authorizations of the RFC interfaces, they are very dependent on each other. So you have to have clean RFC interfaces to also design clean custom RFC authorizations for the RFC users who are hard-coded in the RFC interfaces and the RFC destinations. So we'll have a look at both, firstly at the RFC destinations interfaces and what are the important things in there. And afterwards, we'll have a look at, okay, what can we do for the authorizations, which will then also minimize the risks associated with this topic quite tremendously. So let's get started with a little bit of RFC basics. So RFC communication, RFC is a remote function call, and it's a protocol for communicating between systems, ABAP to ABAP, but also external to ABAP, or ABAP also to external systems. And you can imagine it as a communication channel between systems to call remote functions, remote function modules. And there are a lot of examples for that, which you are always in touch with using SAP. You nearly always have a Solman, where you have Solman monitoring, communicating via RFC. You maybe have a BW system, business warehouse system, where you also always have extraction of data from the so-called child systems to the central system, to the business warehouse systems, also communicating via or extracting data via RFC. There's a central user administration, Fiori Central Hub. If you're using this scenario in an S4 landscape, there's a possibility to use a central hub. This would also be RFC communication, and many, many more scenarios where you have to deal with RFC communication. And for this to work, you need to define these communication channels. And they are defined in so-called RFC interfaces or RFC destination. It's a transaction SM59 in the SAP system, where you have to put in all the necessary parameters like target host, to which system you want to communicate, and also the user. It's a very important parameter, the user which will be used to log in remotely to the target system. This is also very important if we are talking about authorizations, because the user will get the authorizations to log in to the or to authenticate to the target system, and afterwards he will need to have SAP authorizations to do his work in form of executing function modules, extracting business data, etc., etc. And very important here is this architecture. The RFC destinations or RFC interfaces, they are created in the client system or in the calling system. We also like to call it client. So we always have two sides in this RFC combination. We have a calling system and we have a called system. So it's very important to know where you need to analyze which data. So in the client system, in the calling system, you usually want to analyze the RFC interfaces, the RFC destinations, as it is here. RFC interfaces are created on the calling system, but the RFC users, which are called, they are created in the called system, in this so-called server side. It's also in here. So RFC function modules on the called server can be protected using the authorization object as RFC. So on the called system, the server side, there are the users, the RFC users, which are hard-coded in the RFC destinations, and they will need to authenticate in the called system via a password, which is also hard-coded in the destination normally. When we're talking about technical users, of course, there are also other scenarios like trusted RFC, etc., which may be with other parameters, but the usual technical scenarios is with a hard-coded RFC user and a hard-coded password that the RFC user can log into the target system. And of course, he will then need authorizations to execute function modules. And there is a very important authorization object in this scenario, which will control whether or not he can, the technical user can execute function modules. It's so-called S_RFC. And there are different possibilities to authorize for this object. As a you can authorize for function modules themselves for the name. So you can say, okay, this user can execute, for example, RFC_ping, that he can ping another system or can get pinged. Or you can also authorize function groups. Function modules are also grouped together in so-called function groups. You can imagine, or you can compare it like table groups. With tables are grouped into table groups. You can authorize for table names or table groups. Same thing with these function modules and function groups. So if you look at this picture here, normally it's a bit more complicated with this RFC communication in regards or in comparison to dialog users or dialog authorizations, because when you're looking at dialog users and dialog authorizations, you have one system where the user is logging in and either he can work or he cannot work, he has authorization errors, etc. With the RFC communications, you have a lot of systems communicating with each other. So here it's very hard to isolate one system. So if you want to redesign RFC interfaces and also RFC users, you have to look at it on a landscape level. So to really understand which system is calling which system and which user is behind which RFC destination, and to really have an impact and redesign it, you have to look at it on a system landscape level. So what this picture also wants to show you is there are different security requirements in the systems. So what you also need to have in mind in the beginning is what are my systems which need to be secured. So normally you have your production systems with productive data, with all the processes, productive processes, and these are the systems you want to secure. So you will have to identify them and maybe also think about, are there other systems with important data? Sometimes also customers like to copy their productive clients to a test client. So maybe there is also productive data in there which you might want to secure. So these are the questions in the beginning. Which are the important systems you want to have secured? And then you can analyze the RFC destinations which will point to these productive systems, because these are the ones, it's also the ones shown here with these arrows. These are RFC destinations which need to be more secure than maybe RFC destinations which point from a production system in a test system or from a production system in a development system. These are maybe the RFC destinations which are not that much important, but you will need to identify them. So this is the overview of the RFC interface or RFC architecture. And maybe now the two most important things is, there's a client side and there's a server side. There are calling systems and there are called systems. On the one side, on the calling side, there are the RFC destination. On the call side, there are the RFC users with the RFC authorizations. And both sides need to be have a good configuration. So let's have a bit of look. What are the risks involved with this scenario, or especially if you have authorized RFC users in the RFC interfaces? So the problem here is, like with dialog users also, if you have a lot of authorizations like set all or authorization roles like set all, or even less than that, you just need S_RFC with wildcards. You have then the control to manipulate all the business data basically. And you have this opportunity in a way where you have technical users in the destination, so non-personalized, anonymous users, which makes it very hard to audit them in the target system, because the attacker in that scenario would be on another system than the target system. The attacker would be on some development system far away, and he will use these technical users in a production system with generic system users. So like DEDIC, WF batch or something like that, which makes it very hard in target system to audit these changes made. You can maybe do it via security outlook with comparing timestamps, etc. But it's very hard. It's very hard to audit these changes made. And of course, if you have a lot of authorizations in these system users, you can just use an SE37. That's the fourth and fifth point here. If you have SRFC with wildcards in these system user authorizations, you can just use an SE37 and development system, and the administrators, they have these authorizations because they need to develop, execute, and also test function modules in the system. So it's not a big thing to have an SE37 in the development system because that's their job. And they also have the know-how and expertise to use the to develop, execute, and test these function modules. So they can use these with the destinations given to them in the development system to manipulate data in the productive systems if the users behind the RFC interfaces have the according authorizations to do that work. So this is the problem here with these over-authorized RFC users. You have the same risk as with over-authorized dialog users, but it's a lot harder to analyze and audit this scenario. And you can also do it remotely. You don't have to have a user in the target system. You can do it remotely and anonymously with a technical user via SA37, for example. It's one way to just execute a function module called, for example, BAPI user create to create your own user in the productive system, or you can do RFC_retable to get some data, I don't know, some balance or whatever. Very easy to do so. So how to avoid these risks associated with these RFC interfaces and users? First of all, we have a look at that, or that there are different ways to analyze the scenario. As I already told you, there's a client side and there's a server side. So to have an overview of the RFC interface architecture, you need to look at the RFC destinations. Are there any generic or incorrectly classified RFC users? So for example, if you have in all your destinations the DEDIC or WF batch, and you don't classify your RFC users according to, for example, a very good practice is to call the RFC users according to your calling system. So for example, if your calling system is called Xit from the SID, you will call them RFC underscore Xit. So in the target system, you know, this RFC user is getting called from the system Xit. This is a very good practice. Or another very good practice is to use identifiers for the scenario. So for example, if you have a user for Solman, you will call an RFC underscore Solman or RFC underscore BW extract for business warehouse extraction. These are the two best practices regarding these RFC interfaces. So if you have this generic or incorrectly classified RFC users, for example, DEDIC or WF batch, which in the target system, you don't know what they are doing. They can be called from everywhere. It's not a good practice. It's a bad thing, and it will make your redesign of the authorizations a nightmare. Because if you imagine, if you have in all your interfaces user DEDIC, of course, in the target system, you will have to give them the authorizations for all your interfaces. So at the end, you will, of course, have a role, authorization role, which has SAP all or SAP all-like authorizations. That's why it's very important to have a good RFC interface architecture. This is the first point here. Overview of the RFC interface architecture and vulnerabilities. So first thing to avoid generic or incorrectly classified RFC users, very important. Second topic, which you can optimize also for the RFC interfaces, is another parameter in the SM59, is to have an encryption. So if your technical users want to authenticate in the target systems, you may want to consider encryption in doing so, so no one can read out passwords, etc. Therefore, same thing as with dialog users, that you can use SNC, Secure Network Communication, or SSL, depending on the type of the RFC interface. What you can also, or what you should also avoid are other inconsistencies. There are scenarios like if you have a trusted RFC destinations and a permanent user, a hard-coded user in the destination, this user can authenticate in the target system without password. The trusted RFC means that you don't have to authenticate in the target system. You don't need a password. These two systems trust each other. So if you have a user on the system, you don't need a password to log in there. And if you have a hard-coded user, a permanent user in the destination, he will not have to log in with his password. It's a very tricky scenario and also dangerous scenario. So trusted RFC normally is not for permanent users, but for the own dialog user. If you want to use it in a way like to jump from one system to another system in business processing, then you can use trusted RFC, but not for technical RFC users. What you can also have is other inconsistencies in the connection settings. Target host is unavailable, so you can't ping your system. The RFC destination is dead. You can have authorization groups for RFC destinations, another thing to secure the RFC destination. And we'll have a look at it in a second. There are two things you can do to analyze this important topic here. There is a substandard report, it's called RSRFC check, which you can locally run and analyze the system for the RFC destinations locally. Or we have an Xiting-developed tool where you can also do it locally. So for example, you can install it in your Solman, and he can analyze all the systems connected to your Solman and what RFC destinations are in these systems, how are they designed according to the best practices we discussed here. And you can also do not only analysis, but also housekeeping for these destinations. Very important topic here. What you can also do to analyze the scenario is to identify over-authorized RFC users. Very easy, SRFC wildcard as we talked about. You can also have a look at it with the statistics data. We also have tools for that. We have exciting RFC stock tag tool. It's also freeware, which will analyze your ST03N and will look for active RFC users in your server system, in the target system. And after that, if you have done your homework in the first two parts, you can then come up with a best practice concept for the RFC interfaces and RFC interface users. So some things I already talked about. The best practice is to use dedicated RFC interface users, for example, according to the calling system, RFC_SID, for example, or according to the scenario or application. Or of course, you can also combine these two best practices. So we have one example here, RFC_SID_scenario. So to combine these two best practices of the naming convention of these RFC users. Then you can design custom authorizations in a authorization redesign. There you have to do the same work like in the dialog user redesigns. You have to come up with role design. You have to test your roles. You have to prepare a go live with these roles. We have a look at it in a second. And after all these things, you can consider additional RFC hardening, encryption, RFC callback scenario, UCON, or also protecting your gateway. So we have a short look at what we use to analyze destinations. So we have a tool where we can analyze destinations in multiple systems or central. So for example, we have system DEM, S4X, X53, XEE, etc. We analyze the RFC destinations there and what are the target hosts, and therefore we can then read out, according to the target hosts, what are the target systems. This information normally wouldn't be available to you. We use a methodology to analyze this, to know what is the target system. So then you know in S4X or in here in the system S4X, you have a connection from them to S4X with the user kludge tag, and therefore this user kludge tag is not a very good example. You need to have a better naming convention and dedicated RFC users, which would be better suited, for example, RFC_dem in this example. What you can also do in this view is you can check if the destination is working or not. You have here this ping, which you can use to see whether or not this RFC destination is working at the moment. And if it's not working, of course, you cannot see the target system because it's not available. And therefore, you can come up with a best practice concept regarding these RFC interfaces. You can filter this and then come up with RFC_system ID, RFC_scenarios, etc. Yeah, you can also use it for housekeeping. For example, if this RFC user kludge tag is not suited for you, you can change it in the destination for RFC dem, for example, CUA. This is the CUA user. So you can also do housekeeping in here and really refine your RFC interface concept. So this is that. Let's move on. We don't have a lot more time, but it's only 2 or 3 more slides and we're finished. So another tool which you can use to analyze the scenario on the server side, it's also a freeware tool which you can request a copy from our homepage, is the Xiting RFC stock tag tool. This is a tool which we also use in consulting to analyze it on the server side to see how many RFC users are active in the systems, how many destinations are in the system, and to come up with a first impression and also an effort estimation if you wanted to clean up of these RFC interfaces and users. And if you then want to if you have a clean RFC interface structure and a clean RFC architecture, as we talked about with the RFC interfaces, you then can do an RFC authorization redesign. So if they are in sync, if you have a best practice concept regarding your RFC interfaces with the RFC users, to have dedicated RFC users, it's very important to have these. You will have a lot easier time with these RFC authorizations. And for the RFC authorizations, you then have the normal project step, the normal project methodology to do a role design for RFC users or for RFC scenarios. These are the typical role types. You build roles for RFC users or build roles for RFC scenarios, which you can then reuse also for other systems. For example, business warehouse extraction, solvent monitoring, CUA, identity management, GRC, etc. Then we use a methodology, so-called productive test simulation, which you very comfortably can trace and test these users or test the authorizations in a productive system. And you can do it in a way which will not harm the technical users. They will work with their old former roles. And in the background, we can test the new roles which we build in the role design via statistic data. We know via statistic data which function modules are executed in the last X months. We build a role for them, a custom role, and we can test it very comfortably in the background in the backpack here. And we'll find out exactly which authorizations are needed for this user. So we really have a custom need-to-know role for the user. And after this productive test simulation, which will normally run 2 to 3 months, you can do a protective go live. It's a third phase here, which we also use our software to help you with the process. We use the protected go live, which will also support you with an airbag. If the user goes live with the new authorizations, you have just like in the productive test simulation, a backpack with the former roles, which if there are errors, he will automatically assign the backpack to the user, so the technical user will not experience any dumps. This is for some time we use this methodology as a last security a method to really have a protected go live and ensure a smooth working process. So to sum that all up, we looked at the basics, the risks, and then the second important thing is to analyze and design your RFC interfaces according to your best practices. We talked about dedicated RFC users. These are very important. And afterwards, you then can really design custom need-to-know authorizations according to this project methodology. What you can also do afterwards, there are additional steps which you will help with your RFC security and harden your RFC security. There are RFC callback whitelists. This is a very special scenario in this RFC communication. When you call a system, the call system has always the opportunity to call you back. It's the so-called RFC callback. And you also want to secure this scenario here. It's also very easy to manipulate. There are Yukon whitelists, also like a firewall. There are authorization groups for RFC destinations, so you can additionally secure or protect very important systems. For example, there's the possibility to encrypt the authentication process. Just like with the dialog users, you want to encrypt the authentication. And another thing what you can do is to protect connecting in the sub gateway via this RCL files, recinfo, secinfo. You can secure just like a firewall in there. Another very important topic Also, technical users, what is very similar to that is the concept for batch users. So everything which is running in periodic background jobs, you can also design an authorization concept for that. And you also want to consider using need-to-know authorization for these batch users. Depending on who can use these batch users, you can also maybe manipulate this system, these technical users for your own agenda. So this is the topic RFC security. Thank you for staying with me additionally 5 minutes, and have a nice day forwards. For me, it's now evening, so, but I think for you, something like lunchtime. So have a nice day.
Thanks, Marc. And we got a couple of more questions that we couldn't get to, so we'll answer them via email. So stay tuned for an email in the next couple of days, probably by tomorrow. And thanks again, Marc. Very good presentation. Appreciate it.
Thank you, Michael.
Bye.